Today we have a brand new battery to test and unbox and go over, and we're going to do the unboxing. We're going to go do a general overview of all the specs on the battery. We will go over the Bluetooth and the gauge that goes into this battery and gets plugged in, and how that might be different than previous batteries or other batteries you might have seen. Once we're done, we're going to do the OTA update, the over-the-air update to this battery, to show you how it's done. It's pretty simple. We'll do it on this tablet right here so that it's perfectly viewable. And we'll go over some of the features and some of the things about the harness, a couple things you need to know. Then we're going to go over how to commission this battery, how to get this battery ready to put in your boat or RV or whatever it is you're going to use it for. There's a few steps that you should do, especially if you get the battery and you have it on the bench before it goes into your camper or boat. It's best to unbox it, do these commissioning steps to make sure there's nothing wrong with the battery prior to taking it down to the boat. I get a lot of people that have gotten their batteries. I had one guy recently who received his battery 3 years ago, and then he just put it in the other day. So now he's got all kinds of questions. If you get your battery, unbox it, test it out immediately, and go through a couple charge cycles. We'll go through all that in just a little bit. And then finally we're going to cap check it using this iTech 8514C unit right here, which is very accurate. It's lab standard equipment. It's in calibration. It's an expensive piece of equipment. So I've been testing it on various batteries here over the last couple of days, and it works very, very good. It's very accurate, amp hours to 3 decimal points. So we're going to do some testing on that for capacity and commissioning. So, all right, let's get started. All right, we're going to unbox this. This has not been opened at all. This battery is not a ringer or something like that. It's just an average battery that you would get from Epoch. Hard part about this unboxing is actually getting the dang battery out of the box and good packaging. One other thing about boxes: save your box. Save your box. If you ever do have a warranty, and the warranty is good for Epoch, if you ever do have a warranty issue and you have to ship the battery back for repair or any other things, or just an exchange, or ship it for any particular reason, you're going to be in trouble if you have to ship it back and we don't have spare boxes. Save your box. Just put it in the attic, out of the way. But if you get 4 batteries, save 2 boxes or something like that. Just save your box. It might come in handy one day, even if you ship it to somebody else and selling it or something in the future. It's a good idea to save the box. And we got some screws here. We have a gauge and a gauge holder mount. And we've got all of the harness. We've got a remote switch, and we've got the rest of the harness. Now, one thing real quick, when you get this harness, right here, okay, in this right here, there is a plug. It's got 2 partially stripped wires on it, and it's labeled debug. All right, so when you get this, take this off and put it away for safekeeping. What this is if there's ever a problem with an OTA update or a firmware update or any type of firmware issue, which does happen from time to time, the guys at Epoch thought of this ahead of time. This is the plug that you would use when we send out the tablet to directly download a firmware update. So anytime you're doing over-the-air stuff, you could lose signal, you could do, there's a couple things that could happen. You could forget and walk away, and we've had that happen on occasion. And what we do is, instead of you having to take this battery out of your boat or camper that's already installed and you've done a lot of work, we'll just send you a tablet. You plug it in, you plug this in to this harness. This is plugged into the unit that we send you, and then in like 30 seconds you do an update directly. So it's a lot better doing it this way than it is having to ship a battery back and forth, so we could do it at the lab. So when you get it, disconnect this plug, put it away for safekeeping. All right, so here's the main harness, and this is a very long remote power switch right here. And of course, a manual that has all kinds of stuff in it. It's got all your dip switch settings. So that's pretty much it. Let me see if I can get this dang battery out of here. All right, so we are going to go over each one of these items and how to hook them up. In addition, how to get it on our tablet or phone for Bluetooth. You've got your harness here. You've got a gauge here. Gauge has a 6-pin connector. So on your harness, just find this 6-pin connector. You can see it has a little catch on it, which goes right here on the top. So that would just go in there like so and clips on. All right. From there, we have really only two ends. There's some other things in here, but one of them was that debug plug, and the other one is something that we're not concerned about. So the two RJ45 connectors are the ones that we're concerned about. So this gray one is labeled Victron. Eventually, if you're using Victron, that'll be plugged into your servo. The one we need right now is this one, and it's got a waterproof bung on it, which is a clue that it goes in one of these two. In this case, it goes into the blue one. So we're going to plug it into the blue one. Here, my little gauge. Come on, it says welcome. Battery was shipped with 51%. We're at 52.7 volts, 0 amps. So from there, let's see if I can get this to sit up here. Good enough. Okay, from there, we can go to our Epoch app. Okay. So we're going to go to the Epoch Lion app, not the Pro app, the Epoch Lion app. All right. And when that comes up, you're in the Bluetooth tab. Bluetooth tab shows all the potential batteries that you might have. In this case, it's done by distance. So the closest one is this battery. Closest Bluetooth source is this battery, which is at the top. So turn it on. If I hit it, there we go. So nothing's changed because you have to go to the dashboard tab. Okay, now we're on the Bluetooth and we see the same 51% and 52.6, 52.7 volts, 0 amps, 0 watts. We are at V2.2 firmware version. So at some point in just a minute, we're going to do that. But before we do that, let's do this. This is the remote power switch. It's very, very long. Can be used at long distances, especially for big boats or big campers. Now that plugs in over here. Let me turn this around. So that plugs in over here. It's just a 4-pin connector with a little keyway. There's a little keyway in there. So just put it in there and turn it till it pops in, and then turn it all the way around. And then you'll notice that is powered up as well. If we were to hit this light would go out and that light would go out. Of course, I don't need it to do that. So one other thing about this, it has this little plug right here to separate this unit. On the very first version of this, on the V1, we didn't have anything separated, and it was kind of a pain to get this plug through the hole, and it was the same size as this. So now they've separated it, so you can drill your little hole right here. I don't remember the size, 1/2 inch, 3/4, something like that, and then snake this through and then run this from the other side in your boat or camper. Makes it a lot easier. So that was very good. All right, and on this side, just to demonstrate, I am plugged into the blue port. All right, so we're at V2.2 firmware update, and we're going to do the OTA, the over-the-air update. My compressor. So we're going to do that now. It's pretty simple. The latest update as the date of this video is V2.7. It's going to be a while before there's any additional updates, and there'll be very minor updates from here on out. Things that you probably wouldn't even notice, but things that would improve the performance of the battery or tweak balancing or something like that in the future. But for right now, we're going to update from V2.2 to V2.7. So to do that, we are going to click on About, and then so that bottom tab About is lit up, and then you see the OTA button. Now when I press the OTA button, it's just one tap, and then at this point I should get Step 1 EMS update, and then I should get Step 2 BMS update. They'll both be here. Obviously select Step 1, and then we'll do the whole update, and you can see what that looks like. Then we will come back and we will do Step 2 BMS update. So let's do Step 1. Here we go. Step 1 EMS update. And then you see Step 2 BMS update. Obviously we want Step 1 update. Okay, and then up pops this Start button. So when you get the Start button, hit Start. and now we see it updating. Okay, so we see the counter counting up, and you see that counting up as well. So there's nothing to do here but just wait a few minutes. It might take a minute or two. All right, we've got step 1 EMS updated. This cycled off momentarily, which disconnected our Bluetooth, because again the Bluetooth is in the gauge. So we are going to have to turn the battery back on, and we're back to the dashboard, and again go to About, go to OTA. Now when we do it, we are only going to do step 2 BMS to 2.7. So click that. And then hit start. And in this way, this lags, or this gauge lags just a little bit behind there. So don't touch anything until they both are completely done. And we'll come back when we're a little bit closer. So it starts to pick up speed at the end here. We're at 91%. Continuing to go, 94, 95. The gauge is reading about the same. 99, 100%, and that's it. So again, it shut off momentarily. It was very quick. Here is the battery. Go to the dashboard. Wait till it populates here, and we're up to V2.7. So that's a successful update of the battery, and the battery is now ready to use. Just a note about OTAs. The main reason for the OTAs is the ability to keep pace with Victron systems. If Victron adds features, or we add features that could be compatible in Victron, we can update it remotely. Victron stuff is always changing rapidly. As you see, they just came out with a bunch of new stuff. Love my Victron stuff. So this allows the battery to keep pace with that. And in addition, if there's any improvements that we can do to the battery for performance, we can do that via the OTA updates as well. I don't anticipate many OTA updates after this V2.7. It'll be a while before we have an update, unless there's a major Victron update or item that could be used by the battery. Let's move on. All right, we got to load this on the new battery bench. Be careful, because these things are heavy. Hooking this up to my power supply. So these power supplies you can get on Amazon for very, very cheap, and they come in handy for things like this. So this is just what we're going to be charging with. Normally you could use like a 48-volt charger or whatever it is that you were going to use. You could use your Victron equipment, whatever, but in this case for commissioning, I'm going to use this power supply because we're going to set it to a particular voltage and see how the battery is currently, and then do some charges and discharges. Alright, so to get the app back on so we can monitor everything, again, gauge plugged into the blue port, and then we will put our gauge up here so we can see it. The Epoch Lion app, and there's our battery. Came to the top. A lot of times if you have already synced to the battery once, it'll automatically come on and go to the top. So we go to the dashboard. So we're at 52.6 volts. We're at 51%. Our final target to get this battery up to speed is 56.8 volts. That would be the absorption voltage that, if you were in communication with Victron, that would be the absorption voltage that it would go to. And we're currently charging with 21 amps. And of course the battery voltage is 53.78, 53.8 being put out right now. But we are charging with 21.1 amps, which is what we have here. From here, it's going to take about 3 hours to charge. Right now I want to charge with as many amps as we can. I think that's all I can get out of it. And we're charging with 1132 watts. And as you see, the voltage is coming up slightly. So we'll have to check back on this in about 2 hours. Alright, we're still on the initial charge here. Charging at 12.5 amps. I had to turn it down because my power strip back there kept popping the switch. We are at 99% on this initial charge at 54.5 volts. Still taking in 12.5 amps. If we go to the cells tab, we're at 009 volt differential. Now it shows 99%, and so we're getting close there. SOC is moderately accurate, so never count on SOC to be perfectly accurate. But from here, the voltage will begin to rise very quickly. 54.6. You'll see it spend a lot of time during the charge in a mid-level voltage, but once it gets up into the upper knee, you'll see that voltage start to climb very rapidly. You can see on the app there it says 99.2. So when this gets up around 99.5, 99.7, that voltage will start to climb pretty rapidly. Up to 56.8 is what our target is because I think that's what we have here. Let me see. Yeah, we've got 56.8 as our target, and that's in the middle of the upper knee. That's not the upper knee. 3.65 volts per cell would be the top of the upper knee. We don't need to go there, especially on the very first charge. So, all right, we'll come back here when it gets a little bit more full. Alright, so we're done charging. We're going to set up our fancy machine here. We're going to go shift, battery. We're at 20 amps, so enter. Stop voltage is 0 because the BMS is what's going to do the stopping at low voltage disconnect. Stop capacity is 999 because we're just going to be somewhere around 100, 102 maybe. And the timer is just set exceedingly long. Save battery file and then trigger. And so we are pulling 19.999 amps. Counting the amp hours to 3 digits. Let's check it with the clamp meter here. That machine up there is way more accurate than this clamp meter. So we're showing 20 amps here and 19.999 there. So that's good enough. So we're just going to let this run. It's going to take about 5 hours. And we'll come back in the morning. Alright. Alright, I just got to capture this. So we are currently at 97 amp hours. Just getting ready to hit over 97 amp hours. The voltage average is 3.123. According to this, we have 1% to go, but we'll see if that's accurate. We're at exactly 50 volts. Just crossed 97 amp hours. But one of the things I wanted to highlight was that SOC is not perfectly accurate. We're probably going to go to 0 here and continue to put out for a little while. Yeah, load holds exactly 25 amps. And this piece of equipment tracks amp hours down to 3 decimals. I certainly don't actually need anything that accurate. However, it's nice to have something that's extremely repeatable and reliable, just so we know. Alright, so we just hit 0.1. We're at 0. We've been at 0 for a while now. We're at 98.3, 98.4 amp hours. And there we go, we're at 0 and we're still going, still holding at 49.8 volts and still over 3 volts per cell. So it's still kind of hanging in there. So almost hit 99. Still going. Voltage average still 3.1. The differential is starting to grow a little bit as we get into the lower knee, and that'll grow more. Alright, gonna hit 99 amp hours. Just a second. Still at 0.0 out of 100 amp hours. Just to show everybody that that is just a rudimentary counter. Okay, we're at 99.2 roughly. Still holding strong above 3. So we still got a little bit to go. What do you think? 102, 103 amp hours? I'm not real sure. We're going to hit 100 now momentarily. And again, these are 100 amp hour cells. These are not 105s. A lot of batteries that call themselves 100 amp hour batteries come with 105 amp hour cells. Well, for the architecture of this case that we really like, same case as the 24 and 12 volt batteries, we used different cells, and what we could fit in there was the 100 amp hour cells. So there's a slightly less bit of energy, total energy contained in the 48 volt than the 12 volt. However, this battery is also $200 cheaper than these versions, basically for that reason. So we're going to hit 100 amp hours here momentarily. Still above 3 volts. Holding strong. I'm going to hit 100 here momentarily. I'll get that glare out of there. One other thing to note, look at the voltage on the left side. 49.15, dropping now pretty good, but of course you're reading 3 decimals, but 49.1, 49.2. The voltage drop under 25 amp load, these wires they're only 2 gauge, I think, or 4 gauge, and these things are ice cold. 48 volts is incredible as compared to 12. There's a lot of energy in a 12 volt battery, but you're going to lose some of it to wires, even 4-aught wires, under the equivalent watts taken out of a 12 volt battery as compared to a 48. So our voltage is starting to nosedive now. You can see at 48.9, and you can see it really start to nosedive. So that tells me we're in the lower knee, and we're starting to really fall. So we're over 100 amp hours. That's good. Still above 3 volts though per cell. The VDIF is growing slightly. I mean, we're pulling 1200 watts, 1225 watts out of this thing. Been doing it for over 4 hours now. It's like running a hairdryer for 4 hours off one battery. Let's keep an eye on the cell voltage. And VDIF is growing. The low volt is still over 3 volts. The V low. Lowest cell is still over 3 volts. Pretty impressive. Actually, this is lasting longer than I thought it would be, so I'm going to cut the video for a second, come back. Okay, so we're cap checking the Epoch 48 volt 100 amp hour battery. We're just about to the end of the test here. We're using the iTech 8514C Plus load tester. It's in cal, it's brand new, it's an expensive piece of equipment. Measures amp hours to 3 decimals. And we're pulling 25 amps, so this is a 0.25C load. I think the V low here, we've got a little bit of VDIF. The total voltage is just nosediving now because we're at the very end. All right, we're at 45 volts, so I believe it's 2.7 or 2.75 where the low voltage cutoff is. I could be wrong. It might even be 2.5, but we're about to find out. All right, so the VDEF is starting to rise because we're in the lower knee, just like it would diverge at the upper knee. And we are at 104.3 amp hours, which is pretty good. So that's pretty good. And again, these are not 105 amp hour cells. These are actually 100 amp hour cells. To fit 16 cells in series in this case required, we're getting cell undervolt. We might have stopped. Nope, we're still going a little bit. That's a pre-warning here, so we're about to get cell undervolt. Let's take a look. Yeah, we're still, discharge MOSFET still on. We're about to have it shut off any second now. So we're at 2.6, maybe it is 2.5. But anyways, to fit 16 cells in here, we had to package 16 100 amp hour cells. In the 24 and 12 volt batteries. They're a little bit larger cells than these, so that's why these are actually $200 less as well. These are $200 less as compared to these as well, but there's still plenty of energy at 48 volts, plus you get a lot less losses. So let's wait for this discharge MOSFET to shut off, and it's going to be determined most likely by that low cell right there. Let's see, we're going to hit 105. Should be any second now here. We're at 2.585. In the lower knee, this is where the voltage really starts to nosedive. So I guess it is 2.5. We're about to find out. So watch the bottom right hand discharge MOSFET and V low. Okay, there it goes. So it's actually 2.5, but with a time period. Could have been 10 seconds or 30 seconds. So as you see, the discharge MOSFET is off. We ended up with 105.279 amp hours. Pretty good for its very first charge and discharge. No problem. So anyways, that's pretty good. A little bit of rebound voltage. That voltage will creep up now that there's no load on it. But all in all, 105.277 amp hours. Took a little over 4 hours to get this done on a brand new out of the box Epoch 100 amp hour 48 volt marine battery V2 Elite with Victron comms. Alright, and as you see, we also have the flashing light there, which is for the warning. Alright, more later.